All right, we are going to begin the last talk of the day. I will briefly introduce Josh and John. They're actually my coworkers at Digital Security. We go way back, all sorts of shenanigans, but now we're fighting the good fight to protect Mac computers from all sorts of evil things. So I'm really excited about their talk. Try to save, a really interesting talk for the last one of the day, so everyone's still sticking around. So with no further ado, here is Josh and John. Let's give them a round of applause.
All right, thank you, Patrick. So aloha, everybody. Last talk of the day here. Only thing between us and happy hour in Maui. So we'll without further ado, we'll get going here. So, all right. So today we're going to talk about our leveraging Apple's game engine to detect macOS threats. Like Patrick said, I'm John. My coworker Josh is going to be also presenting with me today. And along with Patrick, we are the co-founders of Digital Security. All right, so today we're going to talk about what do we do here at Digital Security. So we want to talk about some of the tools that we've been developing over the past few months and just want to share with you today to get it out there. So when we got together, the main idea behind Digita is we wanted to take all of these great Objective-C tools that Patrick's been working on over the past few years and see how we could get them more into the enterprise. They provide great kind of personal protection. They're great for cybersecurity researchers, all those sorts of things. So we want to look at it and say, okay, how can we take it and get it over there? And so we looked at all of the tools, and we thought, how can we improve upon this design? We don't just want to take each individual tool, kind of bundle it up, duct tape it all together, but we really wanted to reimagine what we could do with all of these great tools. Particularly, we wanted to make it so that we could take a new idea or when a new threat comes out, that sort of thing, that we're able to quickly react to it and deploy detections for that without having to create a new tool, test it out, deploy it, and all of those sorts of things. So we want it to be a very quick and versatile detection engine that we could easily extend. So we decided to kind of have a look at it, and today we're going to talk about that overall redesign and what we did. So first off, we're going to start off by introducing what we're calling MonitorKit. So kind of it's our open source framework that we use as the basis for our tool. Then get into doing some game engine based analysis, and then followed by how do we use these things in conjunction to look at some real world kind of recent macOS threats. All right, so first off, going to talk about MonitorKit. Our goal with MonitorKit was to create an easy to use framework that provides basically a lot or all of the monitoring capabilities that macOS has built in. So, we kind of looked at it and we said, hey, we need to develop this for a lot of the tools we're building. Patrick's built a lot of this as well. So, hey, why not open source it and get it out there? So, we kind of put all this together into an easy to use framework. And then along the way, we also took a lot of steps to optimize the different monitors, look for different ways to kind of, clean that up and make it really easy to get access to this information. So I will say there are lots of great code samples out there for accessing audit-D BSM records and all of those sorts of things. Jonathan Levin has awesome tools and a lot of things like that. Patrick has his tools as well as things like XNUMon. But we wanted to kind of bring all that together into an easily extendable framework. So kind of as we go through this, not going to go into too much of the details of how FS events work and that sort of thing. Plus the code will be open source here in the coming weeks, so you'll be able to look at it all. So first off, talk about the framework. We wrote it all in Swift, and so it's an easily usable and extendable framework. As we're going along, for all of you Objective-C with a C fan, we also made it fully Objective-C compatible. So in the first release, we're going to have interfaces for the monitoring of process, authorization, file, downloads, screenshots, USB devices, and synthetic click system level events. So we're utilizing many different types of monitors, which we'll kind of go through here for each of them. But in general, the standard usage for all of these monitors, we tried to make it really simple. And it's basically you instantiate an object in Swift, you call start, and then you get a call back with that event already filled in. So behind the scenes, it's doing all the parsing, it's doing all the linking of different data all together, so it's really simple to use. Those events you get back, and then they are fully codable within Swift, so that's easy. You can output to JSON if you're crazy and you want to output to plist. Also, you can do that pretty easily. But should be pretty simple. If you just wanted to write a monitor of all new processes or all new authorization events, you could probably write that in just a few lines of Swift code. All right, so I'll talk a little bit about the OpenBSM, just because there's a lot there. There's so much to it, and there's just a wealth of information that we can get access to. So BSM is Sun's basic security module, and Mac OS has implemented that and actually has really good support for it within the system. So kind of as you know, Richie kind of mentioned earlier, BSM and audit-D and all that kind of stuff is very verbose, very kind of difficult to use because it's a ton of information that's not necessarily well linked. In order to use it, you kind of have to pour through logs and look at a lot of stuff. So we thought we can simplify all of this. Not going to go too much into the details of these audit records, just because, partly because, within MonitorKit, that's all abstracted away from you. It's an easy to use interface. But I will say there's some really good resources out there. Jonathan Levin has a great chapter on the nitty-gritty of all this. Patrick recently did a ShmooCon talk on BSM and using it. So all great resources that they go into details. So I'm not going to go into too much, just to say that at the high level, you're reading off the dev audit pipe there. It's a streaming binary protocol. You get those, you call AU read record. To get the record, within that record, you have a set of tokens, and then within that set of tokens, you get to the real meat of it and all of the data that you're interested in. So things like the arguments that were passed into a program, those sorts of things. So what can we use BSM for, and how does MonitorKit take advantage of that? So within MonitorKit, we have a couple ways to do that. First off, we created an interface, BSM monitor, a simple to use class that you can just instantiate and start capturing all of these system level events. So within that class, you can pass in the audit mask, where you can set the class, the type of events that you want to look at. This is actually part of the BSM API that you can send, and then it will start capturing those sorts of things. So we found that even that wasn't kind of enough to filter down the data. We were still getting tons of data that we didn't necessarily want. So we've extended that so you can also pass in a set of specific record types that you are interested in, and it will return that. So we kind of have that raw BSM class that you can utilize. And then on top of that, we have some pre-configured filters that we've implemented for auth and process events so that you can easily get to those and don't have to worry about what filters to set and that sort of thing. And so definitely going to continue to add to those preset filters as we continue to build out MonitorKit. Okay, so as part of that as well, as we were going through exploring all of these different events, we looked at it and said, okay, this is kind of tough to kind of go through PR audit logs, look at all this stuff. So we wanted to build a UI so we can explore these events and have a look at them. So we built something we call BSM Explorer that looks at the raw, uses the raw interface that's in MonitorKit. And then in the application, you can set the audit class filter that you want, as well as the record types that you want. And so you can fire this up quickly on a machine, start capturing all this stuff, and up top you get the record, and down below you get out all of the parsed out tokens. So nothing, crazy, but we found it definitely very useful for diving into, okay, if we set this audit class filter, what are all the events we're going to get? And how can we have a look at those quickly to see what they are? So this will be a free utility that we'll be releasing alongside MonitorKit as we get that out there. All right, so another monitor that we definitely needed was file I/O. So we decided to go with the FS events to get access to all the different file system activities, such as create file, create directory, all those sorts of things. Lots of different ways to get at this file system information. Things like FS usage is one option that doesn't, unfortunately, allow for multiple subscribers to get access to that. We can also utilize BSM to get access to all of the file system activity, but that also can be extremely chatty. And so we decided to go with the FS events. So Apple actually provides a nice API for accessing these FS events. But unfortunately, when you do that, you don't get access to the process PID that was doing the activity. And so, for us security folks, it's pretty much useless. Like, we can't use that at all because we need to know who's doing it and that sort of thing. So that would be great, Apple, if we just add in the PID. That's all we need in there. It'll make this much easier. But so we're left with parsing out the raw events on there, which isn't too crazy. Again, fortunately, there's great tools out there. FileMon, Jonathan Levin wrote, it works really well. So we're able to take that, model our monitor based on that. And in that, we get access to the PID. So overall, the FS events, really good interface, provides good access to all that system level information. Parsing that binary protocol can be a little bit tricky, but it's all abstracted away. Okay, another monitor that we built into MonitorKit was using Apple Spotlight notifications. So this is great for watching the extended attributes on all of the files that get written out to disk. So you can observe a lot of stuff by doing that. The extended file attributes are great. There's definitely a lot of uses you can get out of that. So within MonitorKit, we built a nice class you can use. You can pass in an NS predicate to say, hey, when this attribute is in there and it has this value, we want to get a notification on that. So really not too bad to use. We built, on top of that interface, we built specific monitors to look for downloaded files as well as screenshots. To make it super simple, you can just download monitor.start, and now you're getting all the screenshots. So really easy. One thing to keep in mind with this particular monitor is that you're left with only looking at the files and directories that Spotlight actually indexes and looks at. So you don't get everything on the disk, only what is configured for Spotlight. All right, another monitor we have on there is from using the Core Graphics event tabs. And so Patrick, again, did a great talk at the latest DEF CON and Black Hat called The Mouse is Mightier Than the Sword. So in this talk, he talks about how malware can use synthetic clicks to bypass different security prompts that are presented to a user. And so, it clicks OK, installs the malware or adware, and they're off. So Patrick did a really good job breaking down this technique. So of course, we got to integrate into MonitorKit. Again, not going too technical with all of this today. The code will be out there soon. This is utilizing the CG event tap create API to get access to click events and keyboard events. And then we can look at those events and say, hey, this was not a user that clicked this, or this was a programmatic click that was on there. And so we're able to detect those synthetic clicks pretty easily. Another note for this particular monitor, Apple actually did fix the bug that was in there that allowed these synthetic clicks. So Mojave is actually immune to these. But we figured we want to get this in here, the monitoring anyways, for those that haven't upgraded yet. All right, and then the final monitor that I'm going to talk about is we're looking at hardware and device notifications. So for this, we're using the standard IOKit Apple APIs, which is the user land framework to access devices and drivers and things like that. So using this, we can get easy access to different devices that are plugged into the system. So for example, someone plugs in a USB drive, we can then get that nice callback to say, hey, there's a brand new USB drive that was plugged in here. We dig into it, pull out all the information, such as the device ID, the vendor ID, all of those sorts of things, and you get that nice event object back, and yeah, simple as that. All right, so another tool that we want to talk about today, it kind of brings all of Monitor Kit together. So we kind of looked and saw, is that playing? Maybe click that. So this particular tool, largely inspired by the Windows sysinternals sysmon tool, has a great GUI you can use for having a look at the system, dynamic malware analysis, all of that sort of thing. So we want to, in that sense, we want to kind of bring it all together into a singular UI tool that you can use for doing your analysis to see, like, when you introduce new malware and that sort of thing, what system level events are triggered, and all of the information that kind of surrounds that. So, just like BSM Explorer, going to be releasing this open source alongside with MonitorKit. All right, so that is MonitorKit. We're looking to get that out here in the coming weeks. Going to get that into our GitHub account very, very soon, and excited to see what you all can build with something like this. Definitely lots of possibilities for building upon this, and want to continue to add to this as well. So we have tons of ideas for new monitors that we're going to add to it as we keep going along. So we plan to add in our Do Not Disturb laptop open events, for example. Want to integrate the oversight microphone and video camera access events, as well as got some ideas on how we can do different detections for different monitoring for keyloggers and that sort of thing. So look for that to be out there very, very soon. All right. So with that, I will pass it off to Josh to talk about analysis.
Thank you, John. All right. So John provided summarized how we extracted many of the Objective-C tool and monitoring capabilities, including process monitoring, file monitoring, device inserts, et cetera. But now it's time to turn our attention to analysis, right? So what do we do with all this data? So to reiterate, one of our major goals in this redesign was to make it simple to add new detections, right? Bonus points if we could abstract the detection logic from the detection execution, right? So for those of you that are familiar, think Yara rules versus the Yara engine, right? But aimed at behavioral indicators that are fed to us by MonitorKit rather than binary pattern matching. So additionally, we thought the analysis should be streaming at its core, so we wanted to keep the analysis on the endpoint. It should be flexible enough to use some historical data, but that we didn't necessarily want to require that you collect all the data on the back end to then do the analysis. We wanted to facilitate some of these hunt workflows that Richie presented earlier, where he does some of the analysis on the back end, but then can push that detection back down onto the endpoint, maybe reduce his volume of collection as he moves forward, or just get real-time streaming alerts and logs of the things that he's actually interested in looking for. So we've noticed that detection actually had been trending away from the endpoint a little bit, right? And we want to just give the users the ability to move back, right? So some additional goals and lessons learned from Patrick and some other vendors. These are some older and recent tweets. We really want to make it easier for analysts and admins and subsequent programmatic logic, right, to make decisions on an object. So in the one tweet, right, you see block catching something, but a user's pretty much asking, like, what do I do with this, right? Okay, great, you gave me a process tree, you gave me this, but I as a user don't really know. Right? So how do we add programmatic logic on top of that? And how do we present that data in maybe a more parsable, like not user friendly, but more parsable way for other analysis tools or users to use in tools like Kibana and such? Additionally, we set out to design a system in which users can add new behavioral detections or adjust the existing ones to meet their unique to meet their unique network needs, right? So, including segmenting your user population, you could load a certain set of logic and detection for one set of users. Like, say they're in, you have different set of logic or users for IT than versus your finance or et cetera, right? So, how do you build up these detections in a way that allows you to segment it in that way, and then adjust, right? If a detection that we think should never happen in the wild, X plus Y is always bad, and in your network it's not bad, right? You should have some recourse there, besides just application whitelisting. So after a little bit of research, John had this, what I consider now a brilliant idea. What if we use a game engine as our detection engine, right? So after all, game engines are constantly being fed events from sensors, modeling them, updating state, evaluating that game logic against the input and the state, and taking appropriate actions such as triggering movements, updating scenes, changing UI, or changing AI behaviors, et cetera, right? So take, for instance, a classic game of Pac-Man, right? User provides input to the system through a controller. That data is modeled, the game state is altered directly and or by a logic controller, which is made up of these logic blocks, right? These little bits of game logic that in total make up the laws of the game, right? The rules of the game. So, for instance, changing a ghost behavior for pursue to flee, right? When Pac-Man eats one of those power pellets, right? So it's worth noting that by a game engine in this context, we're talking about a logic engine, components that define the laws and behaviors, like I said. We're not talking about graphics or cool visualizations or a physics engine or other things that you may associate with a gaming engine. This is the execution of the rules of the game and the logic. So many of you may already see where this is going, right? So we plug in MonitorKit as our sensor. They become the source of our modeled events based on system changes for which we're monitoring. And we keep track of that state through the use of a little kind of look-aside cache or historical cache that allows us to take previous determinations into account when we're looking at the streaming events. The logic controller itself is actually where we will dig in for most of the remainder of this presentation. It interfaces, obviously, with the incoming events, the cache, and our actions to detect and respond, according to its defined logic. So Apple kindly provides a development framework for a gaming engine that they call Gameplay Kit, right? This development framework. And we imagine that the engineers at Apple went to great lengths to make this gaming engine efficient, reliable, easy to use, extendable. So why should we reinvent that wheel, right? These are all the things that we wanted. The framework provides support for a few different types of logic engines. They support things like dishes and trees and pathfinding, and some things that are very ripe for inclusion as we extend the game system as we move forward. But for this first iteration, we focused primarily on rule systems. And this rule system class that they provide, we focused primarily on it because it, by design, separates game design from executable code. So you can load in your game design, execute your game design, execute the logic controller, if you will, and then take action based on that execution at a later time. So it really separates out those two steps. Because GK rule system does allow for fuzzy logic, chaining, mathematical constructs, just about any type of extension that you want to do in code. I've gone ahead and fixed their naming here and called it a GK logic system. I also feel that that's more appropriate and maps better to what we've been talking about today. So at its core, I put together this little code sample here. You can maybe dig into it a little bit later. It's a very, very simple game. But at its core, as we've said, you instantiate a game engine. You load the logic into the system. So you define your logic as a series of NS predicates and outputs based on those NS predicates if they ring true. So in our case, we initiate and load all of our configured detection logic at startup. And then we updated it whenever a configuration change is made by an admin or someone who is administering the logic, right? A new detection comes out, you push it down to the endpoint, it gets added to what is called the agenda, and the next time that agenda gets executed, your detection is updated. At a later time, right, the game engine state is altered, in our case via events from MonitorKit, and the game engine is executed to evaluate the new state of the system given that input, and the output from the engine execution is then inspected and used to drive next steps, right? In our case, we allow an administrator to put right into the detection engine, if this detection block should hit, what should the action be, right? That may be simply caching it for historical purposes. It may be alerting. It may be logging. It may be just let it flow through the rest of the system, but label it in a certain way that further people know that you made some kind of determination. Further detection blocks know that you made some sort of determination on that data already. For instance, in this simple game, right, you can make determinations like flee or hunt, as we talked about before. But like I said, in our case, we're afforded the opportunity to alert, log, otherwise respond, etc. All right, so how do we organize some of this detection logic? We do it in what we internally called game plans, mapped to the MITRE ATT&CK framework that Richie presented earlier. Very good interplay there between these talks. He's already gone in good depth on some of these threats. We had a feeling he would, so we won't rehash much of that. But we do intend to look across the entirety of the attack matrix and begin looking into those techniques, or we began looking into those techniques that are covered by Objective-C tools already, extracting some of that detection logic, as we said before, reimagining those tools, bringing some of that detection logic over into the system, because it's been proven and readily available detection logic, right? And we'll start by looking at some persistence. So as many of you know, block alerts users anytime a process attempts to persist something. We've already covered that a little bit in MonitorKit. So by persist, we mean registering a process or a command to launch in response to an event, whether that's at some time in the future, trigger a launch or a restart, etc. So let's look at how we can deconstruct that logic into its required predicates, right? The beauty here is in the simplicity. The detection logic for block simply becomes a series of 12 of these logic blocks, one of which we have detailed up here at the top. And so, for example, that kernel extension detection, we simply inspect the file IO event that's given to us by MonitorKit, and we determine if its a new directory is being created in the directory that's required for a new kernel extension. And if so, then we tag the data as attempting to persist something, and specifically that it is also a kext. The logic blocks, as I said earlier, do nothing more than label the data, right, as it traverses this whole system. And in our example at the top, right, if the predicate evaluates the true, we label it, as I said, about persist and kext, right? So this labeling then facilitates chaining and logic block reuse, right? So tying this to our previous example, let's say vanilla persistence isn't actionable in your environment, right? Lots of things to ask you to persist, so it may not be actionable, right? We chain this to what I'm calling a what's your sign inspired logic block that extracts and labels an event with code signing information for a static binary or a running process, right? Is it Apple signed, App Store signed, dev signed, etc., right? And what exactly, who signed it, you can also get at that too. So this is a pretty trivial example by design, but to show how simply we can define block and allow it to even further refine in the context of this system, right? This isn't hard-coded anywhere. These can be added. If this isn't deep enough for someone like Richie, we can go deeper, right? You just write a new logic block, and you go and you add it in here to go one step further, right? You can inspect then the architecture of the package or et cetera that he got into earlier, right? So looking at maybe a little bit more of an advanced example here, we'll look at deconstructing ransomware, right? The ransomware detector algorithm that Patrick put out there on Objective-C. If you want to read more about that analysis and that detection capability, you can do so at his blog linked here at the bottom. But it pretty much boils down to a file IO modification of a file in the user's directory. That the process responsible for the file modification is not Apple signed or from the App Store. The file contents are now encrypted, and he does some mathematical stuff to determine that. that the process responsible for that file modification has quickly encrypted several other files. So this is where this example gets a little trickier, because you have to look aside at the cache and you have to determine that this same process has done this multiple times, right? Otherwise, it's just a single process encrypting a single file that may not be as big of a flag as a process encrypting multiple files rapidly. And all of that then would equate to potential ransomware. And you can see the predicates then that are linked together there. So we can tag or label the first or any first iteration of an unsigned process encrypting a file in the user's directory as an untrusted encrypt, just label. And then we can look for those happening quickly in the system as it passes through. Okay, so we've now talked about both MonitorKit and the real-time analysis engine that leverages GameplayKit, but what does this all look like against threats, right? And we've decomposed the Objective-C tools and sort of rebuilt them in the context of the system. So we'll start with another example, and this is a sample of malware discovered in 2017, detailed by Thomas Reed, and then analyzed further by Patrick here. Did some deep dynamic analysis of the tool, right, including creating a custom C2, being able to task it. So it was really cool. We got a good flavor of the capabilities of this sample and how it goes about doing that. That analysis matches closely with our ability to generically detect several indicators, right? So in the first place, right, again, you can generically detect a launch agent being registered, right? Again, that might not be enough, so you just label it, and then you move on. Well, that particular launch agent was attempting to launch a hidden file, right, called .client. So it was attempting to launch a hidden file, so that's a little bit more suspicious, right? Why do that, right? So you tag it with that too, and perhaps that's enough for you, but perhaps it's not, right? And if it's not and you have to go deeper, you have another chance when that file finally launches. It's going to be launched with process arguments that include that include a hidden file, right? And then it also extracts and executes a file out of temp. So again, some of these analysis points and hunt-inspired detections, you can now just load back into the system as we see some of these come. And you can experiment in your own enterprise about what is normal and what isn't, right? You can turn on logging for a little while. You can update it to alerting. You can do what you want to do. Some other detections that are capable, or that we want to add, are things like this particular sample did issue these synthetic clicks to interact and to interact with the user system to allow certain prompts or get access to certain data they shouldn't have had access to. They also did synthetic keyword events to issue commands and controlled the camera, turned the camera on to unsuspecting users. All again behavioral indicators that we can look for using MonitorKit and writing these NS predicate rules. Another one that we kind of took a look at and thought was interesting was this recent WinShift execution vector, right? And this was detailed by the Dark Matter guys at Hack in the Box Singapore, I believe, this year. And in this particular case, right, they were phishing users. They were leveraging this safe open capability of Safari that I'm not quite sure exactly why it exists. It considers PDFs safe, right? So it says, you want me to auto open PDFs and very surprisingly, auto extract archives, right? So this auto archive extracting is pretty a little weird to me, right? So, but combine that now with the fact that this auto archive extracting with another macOS feature that if you drop an app bundle on the file system and that app bundle tries to register as a custom URL handler via just an entry in its plist, the system will go ahead and say, okay, and register you to be launched whenever someone visits that URL scheme. All right, so you can see where this is going. You get phished, you download the zip auto unarchives, the system auto registers that as the custom URL handler, and then they redirect you to something that uses that URL scheme, and the app launches. Right? It does require a little bit of user interaction, but a lot of users will just click OK, right? So how do we go ahead and detect this? So again, looking at just the first level, right? Let's just look for anything that hits the file system that is trying to register as a custom URL handler. We can do this simply by using the modeled and parsed data coming out of MonitorKit and writing this predicate to look at the bundle info dictionary, which is the plist, and then looking at its entry for CF bundle URL types. It's interesting to note here that since all of this are Objective-C types, including a dictionary, we didn't write any custom parsing code for this. This is all NS predicate-based ability in Objective-C. You just keep using Objective-C selectors and digging in, right? This includes string functions that you can use at will in the NS predicate logic and some of the parsing things. So by modeling the data and allowing you to drill into file, bundle, info dictionary, from there, it's just a plist dictionary. You can use built-in types to then parse that. So looking here, then we're looking, is there a CF bundle URL type that isn't nil, right? So is something trying to register as a custom URL handler? And if that's not enough, we can go deeper, right? So was that file written by Safari? That is probably odd, right? There probably shouldn't be writing files directly from Safari that are apps. You should be getting those from the App Store, or they should be coming down as zips, and you should be unarchiving them yourself. Safari shouldn't be doing it for you. Or if you want to go more generic, maybe you want to say, look, I really only want custom URL handlers that are, Apple developed or coming from the App Store, not signed by some random development ID. Because there are some legitimate apps like Shazam or I believe Zoom that do use this technique to launch their app on your desktop when you visit a certain URL in your calendar, for instance, right? So here's my favorite ad word detector. I will admit that I have not had the opportunity to run this at scale yet, so anyone who has, but pretty much if the process claims to be Adobe or Flash and isn't signed by Adobe systems, maybe we should note that. So based on the tools, techniques, and the technology that we've presented here today, Digita's built our flagship product, and we've aptly named it Game Plan, a little play-off gameplay kit. And we're excited to announce that early next year, we'll be releasing this technology in a single enterprise solution that allows for a flexible configuration of this detection logic, separation of profiles to different users, to facilitate endpoint alerting, auditing, threat hunting. You control how verbose this product is based on your configuration. So please contact us to learn more about Game Plan, arrange a demo, or just discuss Mac security in general. We love to talk about this stuff. Look for an announcement, as John said earlier, about our release of MonitorKit to our GitHub account in the coming weeks. And we'll be around for the rest of the conference. For those of you who are also attending MacTechCon in LA, we'll be there as well. And so mahalo for taking the time to attend our talk today. And we look forward to hanging with you in beautiful Maui. Time for questions? Any questions? How'd we do on time?
Great. Time for questions. So the MonitorKit UI that you mentioned, can you get that data dumped to like JSON to like play with it on your own? Like can you get access to like that raw data as opposed to just like interacting with it?
So not as built right now, I don't believe?
Yeah, not as built right now, but it's, there's a little bit of code that should be super easy. All those objects are codable with Swift, which allows you to say, I want this to be.
So the question was, can you dump the raw data out of the MonitorKit UI? And John answered, not as built right now, but the way that MonitorKit is built, it would be trivial pretty much to build that. Yes.
The audit stuff. Can you do that from postmortem stuff? Like extract stuff from the dead box or for this? Can I import it into that or the live?
I think John's going to have to come up here and answer questions with the mic.
Currently, that is live only. Yeah, right now. So we're reading the raw things off there. Yep.
Yes, the question was, can you do, can you read sorry. Yeah, can you do the detection postmortem on the BSM monitoring stuff?
Yeah, it'd be interesting to look at if the same, how much applies just looking at some of the PR audit log files and things like that.
Yes, sir.
You talked about a lot of rules and predicates for malware detection. Do you use this also for like insider threat detection, other kind of use cases?
Yes, so I actually realized that as John was going through all the monitors, I did a poor job in the predicate section of outlining how to use all of those monitors. You certainly could, right? All of it is built exactly the same way and extensible. Some of those, the monitor kit detections are built specifically for insider threat in mind. The download monitor, the screenshot monitor are actually more user behavior monitors, not adware or malware monitors. USB insertion, you can combine those things. And yeah, certainly I didn't supply any of those examples today, but it goes exactly hand in hand, right? You define what is odd in your environment. We just didn't get to put those in here. So the question was, can you run that as a service in the cloud, the game plan stuff? Where do you apply the rules? The rules are applied on the endpoint, right? Yeah, they're all applied on the endpoint. I mean, the backend and the configuration is all, cloud-based. So you define the logic in the cloud, through a UI in the cloud, and it gets pushed down its configurations to the endpoint. But all of the logic, that's sort of the design of the system, was to push that logic back down to the endpoint, because we believe there's, other tools out there that do that analysis or allow you to do some of that analysis, your typical SIMs, et cetera, already in the cloud.
What's the performance impact, the way you built it? Because lots of data gets generated, parts and whatever, sounds like really huge amounts of data.
Absolutely. Yeah, that's a very good question. So the question was, what's the performance impact? And so far, we've seen very minimal, based on the fact, and I think part of that, to be quite frank, might be cheating, right? Some of that is being pushed down onto system level, but we've typically seen no more than 5%, depending on what we're doing. But so far we are typically focused on process and file monitoring. So I believe as you add more into the mix, it may tick up a little bit, but we're trying to cap it at 5, right around under 5% would be our.
Well, caveat that with, it's an open system. You can configure that logic to do a lot of stuff, and you could open the floodgates to BSM, and you're going to, raise your resource usage tremendously there. So it's a give and take on that, and we try to hit that balance of getting the right information, enough to write these predicates, to not, using a lot of resources.
I understood that you're kind of remembering some things, labeling them, and saying, okay, this might be interesting later. Is this stuff that you could stream out or save in a kind of package and say, okay, the past 24 hours, this is the stuff you remember because it might be interesting in the future? Have you built something like that?
Yes, absolutely. So the question was, have you built in the ability to get some of that label data off the system? And yes, we currently, again, configurably, you determine whether you cache it or log it, and you can do both. So you could cache and log it, which, or remote log. So you can remote log it off the system. We'll post the data to an endpoint, or you can just write it locally. And we have another tool that we didn't really talk about, called our Cache Explorer, that then you can go in and look into the saved cache data, which is just a giant object store.
We're scared.
So Richie talked this morning a lot about OS query and writing rules and stuff. Could you just briefly talk about how this is different? I mean, there definitely seems to be like some similarities there.
Sure. So how is this different from OS Query? Patrick always asks the hard questions. No, so fundamentally, we looked at it as like streaming versus polling, right? And so OS Query has some capabilities to do some event kind of diffing over time, but not fundamentally built for that, right? More fundamentally built for building these tables that you can query to get I think Richie called them the point in time answers that you're looking for. So that is one of the things that we think is different about the approach, right? And really just looking at doing that streaming analysis and pushing some of that those analytics down and allow it. So you don't have to build a new table for new detections is another big one that people often ask, right? You don't have to go through kind of the structured OS query way to get these new detections. All right. Thank you very much.
Thank you.
All right, let's give one more hand of applause for Josh and John. All right, so that wraps up day one of the first annual Objective by the Sea conference. I briefly want to just reiterate that at 5:30 tonight, we are going to be having the conference party. It's going to be a few rooms down, so basically on this same level, just go out this door and make a right. We have a local Maui company that's helping design the party and do some cool events, so we'll have some VR experiences, some light shows, all sorts of really cool stuff. Also remember to bring your drink tickets that you got at reception so that you can get some free drinks. There'll also be some poo-poos, some appetizers, and of course the ability to buy more drinks. So again, just round of applause for all of you attendees, for the great speakers, wrapping up day number one. And we will see you at the party.